Okay, so today let us discuss the solution of assignment 4 for the course solid state physics. Solid state physics solution for assignment 4. Solution for assignment 4. So, let us see the first question. What is the question here? We have to see the question first. The first question is that what will be the shortest wavelength of continuous X-ray if the applied voltage between cathode and target is 12.4 kV. You know that actually there are two kinds of X-rays, one is called continuous and another is the characteristics X-ray. So, and for the continuous X-ray, okay, question 1, let us write the option first. Afterward, I will discuss how it is coming. Option A. So, what is the continuous X-ray? You know that when the electrons which are accelerated by high voltage and hits the target, if its entire energy converts into entire or part energy is converted into the photon, I mean radiation, then that is a continuous X-ray, and the graph for your continuous X-ray is like this. This is called lambda minimum. This lambda minimum corresponding to the frequency maximum, because you know that C is equal to nu lambda. So, when lambda is minimum, nu maximum, I mean here we have assumed that the entire energy, entire kinetic energy of the electron converts into this radiation. So, in this case we must say, we must write that H nu is equal to your H nu is equal to E V, where V is the applied voltage. This gives H C by lambda is equal to E V. So, when H nu is equal to E V, H C by lambda. So, when nu is maximum, lambda is minimum, this gives lambda m, I mean minimum, is equal to your H C by E V. However, if we convert this into our well used unit like Armstrong, then it is coming 12,400 by V in Armstrong unit. 12.400 by V in Armstrong unit. After converting all this into our frequently used term Armstrong, we will getting this Planck's constant. C is the velocity of light in free space and V is the applied voltage. Okay. So, here applied voltage is your 12.4 kilovolt. So, 12.4 kilovolt means 12.4 into 1000, 12.4 into 1000, it is in volt, V is in volt. Okay. So, this will give you 1 Armstrong. Thus, your correct option will be A, 1 Armstrong. So, this is the solution for the question 1 of assignment 4. Okay, assignment 4 solution is this. Assignment 4. Okay, so this question is over. Now come to another question, that is question number 2. Question number 2. Yes, question number 2 is what? To study the diffraction, actually it is diffraction. To study the question number 2, to study the diffraction from crystal planes, X-rays are used. Diffraction, or it is written detection, but it is generally actually diffraction of the from the crystal X-rays are used. It is actually diffraction. What I have written here is not right. In your assignment, it is correctly written. It is diffraction. To study the refraction from the crystal, X-rays are used. X-rays are used because of what? One option is given. So, question 2 is solution. First option what is given, that the X-ray photons are very high energy. It is fine, the X-ray photons are of very high energy, no doubt, but that is not the reason for using X-ray for the diffraction through the crystal. The second option is given, that X-rays can penetrate through many solid objects, that is also true, but that is not the reason, because diffraction is not related with the penetration power. C, X-ray is very long wavelength. It is wrong, actually X-rays are of very short wavelength and of high frequency, high energy. So, option D, the wavelength of X-rays are of the order of interplanar spacing. This option D is correct for question number 2, because you know, for the diffraction to be occur, the slit width should be of the order of the wavelength, or the wavelength of the incident beam should be of the order of the slit width, and that is why when we dealing with the electromagnetic waves of very short wavelength, we need the slit like this having very small width, and that is generally available in nature in crystal. That is why for studying the diffraction of X-ray, we use the crystal planes. The interplanar spacing here is actually the slit width, corresponding to slit width. So, for question 2, option D is correct. Now, come to question number 3. Question number 3, that beam of electron is accelerated by potential different v volt and hits the target, and thus produces continuous X-ray of minimum wavelength lambda m. E the energy, E the charge of electron, H Planck's constant, etc. Then what will be the correct option? So, now come to question number 3. So, now come to question number 3, question 3, and let us first write the solution. Option is option first, let us write, afterward I will discuss. So, here option B, option B. Okay, now you may ask how it is coming. See, we have the well known relation E is equal to h nu, that is h c by lambda, h c by lambda. E is equal to h nu is equal to h c by lambda. Now, here what is E? This is actually is equal to E v, where V the applied voltage and E is the charge of electron. So, E v. So, this way if you calculate and if you simplify, you will get H is equal to simply E v lambda m. Why lambda m? Here in this equation we have assumed that the entire kinetic energy of the accelerated electron converts into radiation. So, the frequency of the corresponding radiation will be maximum, and hence the wavelength, the lambda will be minimum. So, thus it is coming E v lambda m by C. So, according to this, option B is correct for the third question. Next, question number 4. Again, let us see the question number 4. For a particular crystal used in Bragg's spectrometer, strong reflection from the sets of plane 1 0 0, 1 1 0 and 1 1 1 are observed for angles theta 1, theta 2, theta 3 respectively in the first order. So, it is the case of first order diffraction, and we have to find the ratio of d 1 0 0, d 1 1 0 and d 1 1 1. So, that is well known Bragg's diffraction relation. Okay. So, now we are discussing question number 4. We are discussing question number 4. So, first I will write the correct option, and after that I will discuss. This is option D. So, how this is very simple. The Bragg's relation, well known, do d sin theta is equal to n lambda. Here our first order diffraction, so n is equal to 1. This gives your sin theta is equal to lambda by 2d, or we have to find the ratio of the d is equal to lambda by sin theta. Thus, d which planes? D, I mean 1 1 D, which planes are there? First plane is D 100, D 100 is to D, next one is D 110, D 110, your next plane 110 is to D, next plane is 111. The ratio will be simply lambda is same for both the all these planes. So, it will be 1 by sin theta 1 is to 1 by sin theta 2 is to 1 by sin theta 3, 1 by sin theta 3. This will be the ratio. So, option D will be the correct. Your question number 4, yes, question number 4, option D will be the correct one. Option D is the correct. Next, we will go to the next question. Question number 5. Here, question number 5. First, let us go through once. Calculate the glancing angle of the 110 plane of a simple cubic crystal. The lattice parameter is given 2.828 Armstrong, corresponding to second order diffraction. Okay, so, this is the case of second order diffraction, and we have to find the glancing angle. So, first I hope you know the what is glancing angle. Till 1 second I will draw a diagram and will show the glancing angle. Actually, in case of crystal diffraction, we generally use this angle, not the this is the crystal plane, this is the normal drawn, and this angle generally used as the glancing angle. It is called the glancing angle. Okay, and for this, your which plane we are discussing. Okay, let us see the question number 5. We are discussing question number 5, and first let me write the option, the option B. So, we have to find the glancing angle. Okay. So, here your plane is 110 plane, HKL is 110 plane, HKL is 110 plane. So, yes, it is 110 plane, and A is given, A is equal to 2.828 Armstrong, and yes. So, and the wavelength of the X-ray, that is lambda is coming 0.75 Armstrong unit, 0.75 Armstrong unit. So, if we see this first DHKL is this is the simple cubic type, this is A by root over of A square plus K square plus L square, that is equal to A by, here plane is 110, so it will be simply A by root 2, it will be A by root 2. Thus, now apply this A by root 2, A is given this 2.828 is by 1.414. If I write this way, it is coming simply 2. So, your D is coming 2 Armstrong. Now, 2D sin theta is equal to n lambda. So, next you apply this formula, 2D sin theta is equal to n lambda. Okay. Here the diffraction occurring from the second order, yeah, n is equal to 2, second order diffraction. So, n is equal to 2. So, just you put this and you will get your sin theta is equal to, or not directly come to theta, not important, you know how to find from theta from sin theta. So, it is your, it will be approximately 22.02 degree, and so by rounding it, it is nearly equal to 22 degree. So, the answer is 22 degree. Your question number 5's option B, question number 5, option B is the correct one. So, next we will focus to the next question, I mean question number 6. We will focus in question number 6. Electrons are accelerated to 100 volt and are reflected from the crystal. The first reflection maximum occurs at glancing angle 30 degree. Determine the interplanar phasing. This is question number 6. So, it is actually it is on the basis of the concept of Davidson-Garmer's experiment, assuming the wave nature of the particle, I mean it is related with the wave particle duality, that electrons when these are accelerated by some potential and reflect from that target, they produce the matter wave. So, and in case, so question number we discussing question number first, let us change the question number 6 and let us write the correct option. Your which option? Question number 6, option B. Question 6 option B. So, here your well known relation lambda is equal to h by p, h Planck's constant and p is the momentum, that is de Broglie relation, lambda is equal to h by p, well known de Broglie relation, the p is the momentum. Now, p is your momentum and energy means kinetic energy, it is p square by let us write in cap small. So, p square by 2 m, m is the mass of electron and it is the electron, the particle under consideration. So, this way if you find and lambda is equal to h by p. So, this is energy E is equal to your E v, where V is the voltage of light, energy is V. So, this will give you lambda is equal to your h by p is equal to root over 2 m E v, and after all these calculations, this comes, I mean putting this data and finally converting all into our well known and frequently used unit, that is in Armstrong unit, it will come 12.27 yes 12.27 by root V in Armstrong unit and V in volt, 12.27 in Armstrong unit, where V must be in volt. So, in our case you see the applied voltage is your 100 volt. So, lambda will come, this will give you 12.27 by root over of 100, this will give you 1.227 Armstrong 12.227 Armstrong. So, now you apply this relation 2d sin theta, again the Bragg's relation 2d sin theta is equal to n lambda and it is the case of first order. So, n is equal to 1 and theta is also given, theta how much it is 30 degree. So, theta is 30 degree, this will give you d is equal to 1.23 Armstrong, d is equal to 1.23 Armstrong is the solution of this question number 6. So, for question number 6, option B is correct. So, question number 6 is over. Now, again we will come to the question page. The question number 7, the monochromatic X-ray beams of wavelength 1 Armstrong are incident on a simple cubic crystal. The first order Bragg reflection from 311 plane occurs at an angle 30 degree from the plane, the lattice parameter. Okay, so, this is the question number 7. Question number 7, the lattice planes, question number 7. So, question number 7, first I will change this numbers, it is 7 and I will change the option, question number 7 and option. The correct option, first let me write, the correct option is D, correct option is D. So, how it is coming we will see. So, in this case your DHKL is given 3111, DHKL it is your 311, this is the plane and thus D is again A by for the simple cubic tip A square plus K square plus L square, this is coming a by, or if you put is this, it will coming a by root over of 11, a by root over of 11. Now, again 2d sin theta. So, again 2d sin theta is equal to n lambda. However, here first order diffraction n is 1, that is equal to lambda, putting n is equal to 1, and thus your 2 into the d is what? D is a by root 11, and sin angle is how much? Angle is your question number 7, yes, angle is 30 degree, sin 30. So, 30 degree. So, this is equal to lambda, this is equal to lambda, and value of lambda, question number 7, you see the value of lambda is 1 Armstrong. So, this is 1, thus your answer is coming a is equal to root over of 11, because sin theta half and 2, this is eliminating, the option is coming a is equal to root over 11, root over 11 is the option D. So, this is the right answer. So, this is the right answer. Okay. Then again we will see the question once again. This is also X-ray question number 8. The X-ray beam of wavelength 1.54 Armstrong reflected from 110 plane of a solid with cubic lattice. The constant is 3.08. For the first order diffraction occur at which angle? So, let us come to the next question number 8. Question number 8. Question 8. It's option, correct option. Correct option is B. Correct option is B. So, and plane, which plane? HKL. It is 110 plane. This will give D is equal to a by root of r of well known a square plus k square plus l square. So, this is coming your this is a by your root of r of root 2, a by root 2, and value of a, question number 8, yes, question number 8, value of a, value of the lattice constant is 3.08. So, a 3.08. So, thus if it is 3.08 divided by root 2, it will come your a is equal to this, which coming a is equal to your 3.08 Armstrong, putting this data, and d is equal to okay, this is a is equal to the given, and d is equal to your 3.08 divided by root 2. So, now we apply this Bragg's relation, 2d sin theta is equal to n lambda, and put n is equal to 1, this will give you sin theta is equal to lambda by sin theta is equal to lambda by 2d. Now, put these values and you will get, finally, you will get this sin theta, I mean this will give you 1 by 2 root 2, 1 by yes, this will give 1 by 2 root 2. After simplifying, you will get thus theta coming sin inverse 1 by 2 root 2. So, theta is equal to sin inverse 1 by 2 root 2, and if you see this option B, sin inverse 1 by 2 root 2 is correct. Option B is the correct one. Okay. So, now we will discuss the next question, but before that we will go through it once again. It is from the reciprocal lattice. The two dimensional lattice has the basis vector A is 2i and B is equal to 2i plus 2j, and find the basis vectors capital A, capital B in reciprocal lattice. This is the question 8, the question number 9. Okay, so question number 9. So question number 9, and we discussing question number 9, and first as previous we will write the correct option. Option A. We will write the correct option, option A. Here, so there is a third vector C will assume along z direction. Along z direction we will assume the C vector, that is actually nothing but the k vector, the orthogonal lattice orthogonal unit vector k. So, we know that in reciprocal lattice A is equal to 2 pi b cross c by A dot b cross c, A dot b cross c. So, what are the other vectors? What are the other vectors A and B? Your A vector, yes, A vector is what? A vector is 2y, and your B vector, this is given, B vector is minus 2y plus 2j, yes, minus 2y plus 2j, yes, is this question is this, yes, minus 2y plus 2j, B vector is given. So, minus 2y plus, yes, what is the B vector? Yeah, yes, A is equal to, yeah, B is minus 2y plus 2j, B is equal to minus 2y plus 2j minus, yes. This question which I have displayed here, maybe there maybe I have omitted minus, but in your assignment you must see this minus symbol is there. Okay. In assignment the minus symbol must be there. So, now we will find B cross C, we will find B cross C, and B cross C is what? B cross C, yeah, this must be minus 2y plus 2j. You check the assignment, there must be that minus symbol is there. Okay. So, cross k, this result giving 2 into I minus j after doing this cross product. Similarly, you will get C cross A, let us find C cross A. C is nothing but the k vector and A is 2i, A is 2i. So, C cross A is only, this is only 2j. Then you apply this formula A and B for the reciprocal lattice, this is okay. So, now also you do A dot B cross C, you do A dot B cross C. Here A is 2i dot 2 into, yes, A is 2i and 2 into I minus j, B cross B, okay, B cross C, I have forgot to write this result B cross C, it is 2 into I minus j. So, this is A dot B cross C, A is 2i dot 2 into I minus j. After doing this, you will get A dot B cross C, it will be 4, it will be 4. Then just you put this in place of A vector and in place of B vector. What is the B vector? B vector is 2 pi, your B vector is 2 pi into C cross A by A dot B cross C. So, this is A dot B cross C. So, this is the B vector. Now, in place of your A vector, in place of this and in place of this B vector, you put these values and then you will get your result. This A will be your pi into I minus j and your B will be pi j. So, A into, so pi into I minus j and B will be pi j. So, option A is correct. So, question 9 is over. Now, the next question, question number 10. So, let us see the question number 10. Question number 10, the diffraction data of a cubic crystal of an element. So, the peaks at 2 theta, these angles. So, we have to determine the lattice parameter of the given element. So, this is question number 10. So, first as usual we will write the question number 10 and its correct option. This option will be B, solution will be B. Here the first let us make a table for the theta, sin theta, etc. So, 2 theta, theta, then value of sin theta, and then value of sin square theta, and their ratio, So, it is 44.46, its half, 22.23, its value comes 0.3783 and 0.1431. Next one is 51.46, half, 25.82, sin theta, 0.4355, sin square theta, 0.1897. Next angle, your 75.78, 37.89, 37 sin theta 0.6141 and 0.3772. Okay, and the last is 93.22, 46.61, 0.7267 and 0.5281. Then what are the ratios coming? You see, this ratio will come, if you simplify it will be 3, 4, 8 and 11. So, 3, 4, 8, 11. So, this is actually indicates that the crystal is FCC type, FCC. So, it is the FCC type crystal, and if we see the value of the A for the first set of plane, that HKL is your 1 1 1 for this FCC, we will get D is equal to A by root 3, and from Bragg's relation again we apply Bragg's relation, 2D sin theta is equal to your n lambda for the first order, it is equal to then lambda, putting n is equal to 1, and then you will get your A. So, A by root 3 into sin theta, how much? Okay, A by root 3 into sin theta. Sin theta, value of sin theta is what? Value of sin theta is your value of sin theta is here. Your where it is, yeah. Value of sin theta is here. So, yeah, 0.3783. Okay, so after simplifying, it is this, you will get the value of A will be your 3.53 Angstrom. So, this will be the solution, 3.53 Angstrom. So, question 10 is over and rest to questions. Rest to questions. Question number 11. From the law photograph of an FCC crystal, it is found that your from the law photograph it is found that the lattice parameter of the unit cell is 4.5 angstrom, the wavelength of X-ray is 0.25 angstrom. We have to determine the distance of the film from the center of the pattern at which reflection occurs from the first set of planes 1, 1, 1 when crystal to film distance is 5 centimeter. Okay, so this is the question number 11, and for question number 11, first as usual let us write the correct option. Question number 11, option question number 11's option is correct option is B, that is 0.48 centimeter. Now, let us see how it is coming, that again that Bragg's diffraction relation d 111 is equal to this is for simple cubic, this is not the Bragg's diffraction relation, h square plus k square is plus l square. This is your a by root 3, it is fine. So, it is coming from again now Bragg's relation sin theta is equal to lambda by 2d. This is sin theta. This gives after calculating you must get this value, your theta will be 2.76 degree. Now, the love photograph, you remember Professor Das has discussed this with a very clean diagram and very elaborately and nicely. I hope you have gone through that lecture. So, if you have gone through and can you remember, then you may see, suppose this is the crystal from where the diffraction is occurring. So, let us see this diagram, and your come to this. So, this is your 2 theta, and we have to find the what? We have to find out the distance of the film from the center. So, distance of the film from the center means this distance x, say this is x. So, this is 2 theta, and this value is also given, it is 5 centimeter, this value is given 5 centimeter. So, simply from this diagram you must write your tan 2 theta is equal to x by 5. So, then you will get x is equal to 0.48 centimeter, putting the value of theta, this 2.76 degree. Okay, so question 11 is over. Now, the last question, question number 12. Question number 12, this matter also Professor Das has discussed very nicely. He has spent enough time such that you can understand the matter. The question 12 is the monochromatic X-ray of wavelength 1.79 angstrom is used to study the powder diffraction, powder sample with the camera radius 57.3 mm. The powder sample is FCC and structure with the lattice parameter is this, and then determine the length of the first order circular arc. This means what? The length of the first order circular arc means actually, if you have gone through Professor Das lecture, then you have seen this, the first order lines are like this, and actually it is asked to find this distance, the distance between two first order from two sides like this, that is actually asked to find out. Okay. So, the last question, question number 12. So, here what are the data? The structure is FCC as a first, question number 12, and okay, option A. What are the data given? See, lambda is given 1.79 angstrom, A is given 4.05 angstrom, A is given 4.05 angstrom, and R, the what is R? This is the radius of the camera radius 57.3 or 57.3 mm. 57.3 mm. So, in case of the FCC, lattice, we know that the ratio of what? H square plus k square plus L square. It comes in this ratio 3:4, 3:4:8:12, like this. So, it comes like this, and it is corresponding to which planes? It is corresponding to, this is corresponding to 1 1 1, this is corresponding to your 2 0 0 2 0 0 1 1 1 2 0 0, this corresponds to 2 2 0, and this corresponds to 1 1 3, like this. So, thus D 1 1 1, D 1 1 1 is A by root 3. This is equal to, A is given 4.05 divided by root 3. This is 4.05 by root 3, and from Bragg's relation, sin theta for 1 1 1 plane is your lambda by d, sorry 2d, lambda by 2d 1 1 1. So, it coming theta 1 1 1 is 22.5 degree, 22.5 degree. Now, here the two relations are to be seen. Two relations, what are these? One relation is here, one relation is your S 4 theta, one relation is 4 theta is equal to S by R, one relation is 4 theta is equal to S by R. However, here theta in radian, and another relation is what? Another relation where 4 theta, your 4 theta is equal to S by R, and another relation is 4 theta is equal to 57.3, what is the camera radius, by R. Here theta in degree, and S is equal to 4 theta, where S in mm. So, note these conversion relations, 4 theta, theta in radian, 4 theta is equal to S by R, 4 theta is equal to 57.3 by R in degree, theta in degree, and S is equal to 4 theta. S is what? This, the distance between two to these diffraction lines of same order. So, you have got theta is 22.5, thus in millimeter, if we find this distance, it is 22.5 into 4. This will be if we multiply, it is approximately 90 mm, approximately it will be 90.1. So, come to this question, your question number 12, the first option A, it is the correct one. And once again I will tell you that your in question number 9, if you find any discrepancy with the answer and the question, if you find that your options is not satisfying whatever provided by us, we must see it, and I think there is no problem, all things are correct. Till if you find anything, you must raise the question in forum and we must find the answer. I think whatever discussed and whatever questions given and whatever options we have chosen, all are correct, but till if you find, we must see your query. Thank you very much for your kind attention. Okay, thank you.